Last week, TSMC themselves, a large semiconductor company that supplies the chips for Tesla, Nvidia, and many others, announced that Tesla's new Dojo AI superchip is now in production and will in the future be 40 times more powerful. This follows news a few months ago that Tesla will be building a new $500 million Dojo data center in Buffalo, New York. Tesla has been heavily investing in AI training compute and is second only to Meta Facebook. They've been both buying Nvidia hardware and now able to massively grow using its own Dojo program. Now that Dojo is in production, this new system on a wafer could deliver 40 times as much computing power as today's systems if all things move forward as planned. I've got Hans Nelson joining us, and as he said, we're going to geek out today. We're going to learn what all of this is about. Welcome, Hans.
Thanks for having me, Herbert.
Follow him on his YouTube channel on Hans C. Nelson if you want to see more geeky, real good explanation of AI, FSD, and bots. So let's start with the news here. You've got Tom. This actually came because TSMC themselves had a conference last year, and it came from them. So this is actually very, more believable news. This isn't just a rumor that Tesla's wafer-sized Dojo processor is now in production. They were putting 25 chips combined into one. Just to remind folks, what this, kind of the system looks like. This is the Exopod that Tesla released. This screenshot of what it looks like, and this is a reminder that several months ago in January, they announced $500 million data center that's going to be in Buffalo, New York. Actually, it says here Dojo supercomputer, but we're not quite yet sure exactly what's going to be in there. And then now the news today, just last week, was that the next gen Dojo AI training tile is in production. So before I explain a little bit more, did you want to add comments on that?
Yeah, we'll just say one of the things is it's the next gen Dojo tile, and so that's not the same as the original Dojo tile that was unveiled at one of the AI days. That one has already been in production. We've been using that, and so this is another version. Elon has talked about there being, Dojo 1, Dojo 1.5, then plans for Dojo 2 and 3 in the future. And my presumption here, my speculation and my opinion is that what TSMC is now building is the Dojo V 1.5 chip, which is very similar in many ways to the Dojo 1 chip, with one very important and very large change that we'll talk about more as we get into this. That is a first of its kind um, manufacturing process and a first of its kind overall system that no one else has attempted before. And it's pretty exciting to see what they're doing in that field. And that has major implications moving forward.
Okay, wonderful. So thank you for explaining that. I mean, it's not only the fact that it's now in production, but you're saying that it's actually upgraded systems. This is exciting, right? Because, we knew that there were some delays in Dojo, but it looks like it's in production and it's going to be powerful, and it's going to add to the Nvidia chips and compute power that they already have. This is going to make Tesla's not only self-reliant, but just grow faster than anyone else's who's just relying on buying the chips. So let's take a look a little bit more on the news, and then we'll get your thoughts on it. So this is the Electric article saying that the next gen Dojo AI training tile is now in production. And it's been heavily, they've been heavily investing in compute power, both buying the NVIDIA hardware and building its own. And so, the Dojo supercomputing platform went into operation last summer. I'll go ahead and play a little clip to remind folks of that beautiful table of they're trying to get to 100 exaflops. And 2 weeks ago, there was rumors, and it sounded like it's actually corroborated that Tesla bought, 100,000 H200s of NVIDIA chips. So they are really past the 100 exaflops at this point. Shortly after, it was reported that Tesla expanded its partnership with TSMC. This is the semiconductor company. This is a comment by some viewer, said the D1 chip was okay, but what's really impressive is putting 25 of them in an area the size of a dinner plate, the training tile, and supplying 15 kilowatts of power to it. It's unclear whether a full system will perform better than an NVIDIA-based supercomputer cluster, but NVIDIA is charging so much for its chips that if Dojo is only 20% as powerful at 10% the cost, it could be worth doing. It's unclear whether Tesla assembled a full working system. So now that they've confirmed, TSMC did, that Tesla's next generation Dojo chip has entered production, and they're working on tech that could deliver much greater power to Dojo in 2027. So yeah, what's your thinking about all that?
Yeah, so it must have gone well when they put Dojo into production use cases. So Tesla actually had working exapods doing useful tasks for the system. It sounds like, from what I've heard from a variety of sources, that the task that the original Dojo tiles were put to work on was the auto labeling pipeline. And this is a very important piece of Tesla's overall full self driving development stack, is that when they take these videos that have been downloaded from the cars in the real world and sent for processing back to the headquarters, at one point they were having to have humans actually go in and label all of those videos, and that was a very slow process. And so they had to develop this auto labeling system, and it was very, very expensive to run that auto labeling system on Nvidia's GPUs. It was just very inefficient the way that that whole system worked, and they were able to put together a system using Dojo that was significantly more efficient for that task. And I think that's how they actually bypassed the auto labeling portion of the process as being the bottleneck, that they solved that problem and they solved it using Dojo. And so that system must have worked pretty well in order for Tesla to then want to go on and increase their partnership with TSMC. And what we actually see them working on is, like I said, it's a first of its kind system that, as we get into the next article, we'll see a little bit more about it. But they're really pushing the boundaries of AI chip design and AI overall system design. And as the one commenter on Fred's article pointed out, one of the really, really hard challenges about what they're doing is they put so many, 25 of these Dojo chips in a 5 by 5 matrix, on the size of a dinner plate, something like this big, and they have to feed it with 15 kilowatts of power, and then they have to dissipate 15 kilowatts of power off of it roughly. Um, and so to be able to put that much power in that small of an area and then suck the heat that that generates back out of the system is a very, very difficult problem. And there was a lot of engineering that went into that. And it seems like apparently that has gone well because they are continuing to scale up the project. So that was another huge one. And then beyond that, there are very significant networking challenges as well, that Tesla has apparently overcome. And so we'll talk more about that as well.
Okay, so here's the actual article that another article from Tom's Hardware, and let's just review what they say because they're a little bit more specific. So one of the last noticed tidbits from last week's TSMC North American Technology Symposium was the announcement that Tesla's Dojo system on a wafer processor for AI training is now in mass production, and is on track to be deployed shortly. So they said, so Tesla has not yet disclosed the performance of its Dojo system on a wafer, though considering all the challenges with its development, it seems poised to be a very powerful solution for AI training. So since the Tesla Dojo training tile essentially packs 25 ultra-high performance processors, it is exceptionally power hungry, requires a sophisticated cooling system. To feed the system on a wafer, Tesla uses a highly complex voltage regulating module that delivers 18,000 amps of power to the compute plane. This is the word you said also, that the latter dissipates as much as 15,000 watts of heat and thus requires liquid cooling. So it's just shocking that Tesla is actually creating these hardware that Nvidia is doing. Like, Nvidia is obviously one of the largest companies in the world now, and here's Tesla doing it also, and they're a car company. So I
Yep.
guess their energy business helps them understand all this and leverage the energy battery storage information to solve this as well. So this is the photo that they did: 5 by 5 array of known good processor chips, 4.5 terabytes bandwidth per edge. Yeah, it's beautiful. Do you comment on
So this is where
this?
we get into the super nerdy, super interesting stuff. So this is what I was talking about when I said this is really first of its kind. There is one other company who is trying to do wafer scale computing, and that is Cerebras. And what they do is they actually have all of their uniform chips kind of spread out across the whole wafer. And what you're looking at here, that round thing, that is a wafer, and it's really the biggest that we can make silicon chips at this point in time. And the problem with making a wafer scale chip, this is the reason that no one really does things at the wafer scale, is that it's impossible to make them all perfect. That there's an error rate, and you lose transistors at a pretty consistent rate, and that you're going to have thousands or however many a specific number at least of bad transistors and then bad chips that would be on that wafer. And so, in order to solve that problem, what Cerebras does is they kind of have a way to say, okay, hey, we know that this one chip in the however many, or this one chip area is not good. And so we're going to kind of avoid that. That's kind of built in. Um, so that has been innovative, and Cerebras actually does have paying customers, and they're really the first person to really try to solve that problem. It comes with some benefits and some drawbacks. One of them being that you don't have on-chip memory that's very good, because the way that you build a chip is different than the way that you build memory. And so you have tons and tons of compute, but you don't necessarily have tons and tons of memory to be able to load and store information for use, and then retrieve that later. This is a problem that also is going to face Tesla in their current implementation of this. But what Tesla has done is, instead of having an entire wafer with a whole bunch of chips on it that you don't know which ones are good and which ones are bad until after it's made, and then you kind of have to accommodate for that in software, what they did originally with the first Dojo was they had their D1 chip, and they would test each of the chips, and they would make sure, and each D1 chip is much smaller than an overall wafer, and they would throw out all the bad ones, and you would have 25 known good D1 chips that they would then put on a traditional circuit board that is used for if you've ever seen the inside of a computer or a motherboard or a processor. It's a green PCB that has all of the different components kind of stuck on top of it. And that's the overall general type of construction method that the Dojo version 1 tile was made with. Here, instead of putting those D1 chips onto a printed circuit board, what they are doing is they are taking those 25 D1 chips, and they're putting them directly back onto a big fat wafer, and they're using the wafer as the way to connect different chips together instead of a printed circuit board. Which, this is what is new, that no one has ever taken known good chips and tried to integrate them directly onto a large silicon wafer before, and use the silicon wafer as the substrate that is doing all of the communicating back and forth between the chips. So Cerebras, they're doing communications between chips as one big integrated chip, but with kind of unknown problems in it. And this is all known good chips. So you're getting the benefits of what Cerebras is doing without having the challenges that Cerebras is going to have to face of knowing that you're going to have bad chips kind of randomly throughout. So that's an exciting and interesting development. And like I said, the challenge that they're going to face in doing that is that they are not going to have access to high bandwidth memory that is nearby each and every one of the chips that they can use to offload data, store it, retrieve it later, and do any of those sorts of things. But that's what TSMC has announced in 2027, is that they're going to have a new type of architecture where they can actually, it's called 3D circuits. You can take some of that high bandwidth memory, and you can actually fuse it on top of your chip. And so you'll have the wafer, you'll have the D1 chip, and then you'll have memory sitting on top of the chip. And that is going to be kind of a next generation way to build AI hardware, that is incredibly exciting, because it means that everything can talk to everything much quicker. It uses much less power, in the process, and it has all of the components that it needs to do exactly what it's going to do. And Tesla, like, this is not an innovation that Nvidia, you would think that Nvidia would be one of the first customers to work with TSMC to develop a process like this. But instead, it's not them. It was Cerebras who was working with them to do the first wafer scale engines, and now it's Tesla that's doing the first integrated chip on wafer uh, technology, and that speaks to Elon and Tesla's willingness to question first principles things, to push the boundaries, and to create a stepping stone. As the first person to have these D1 chips on wafer, or to have chips on wafer, they're going to be in the best position when the new process that TSMC is developing that will have that memory available to be put on top of those chips. They'll already be further down this road developing this hardware and this software. Like, this requires the custom, or the companies that are manufacturing hardware in this way, to rewrite software from the ground up on how to actually operate this hardware. And Tesla will be further ahead than anyone else in that process. Another company I would just recommend people to pay attention to, if this is interesting to them, is Tenstorrent, because Jim Keller, who was one of the integral architects for the hardware 3 computer that Tesla uses, he worked closely with Pete Bannon to develop that. He's got a company that is also producing some pretty fascinating and interesting new hardware for machine learning that is looking to compete with NVIDIA in a way that a lot of people are not anticipating.
Yeah. Thank you for explaining all that. This is very exciting. It just shows you that Tesla is so far ahead. And it's just exciting. This is now in production. This isn't just some
Yep.
sort of dream. It's going to contribute to Tesla's compute power. They're going to, be one of the leaders. One of the things that I really wanted Tesla to do in the new world of AI is they need to be the leader in compute. And they've confirmed they're spending $10 billion a year. Sounds like that they're also building their own. So,
I think
with all that data, yeah,
this might actually bring into sharper focus part of what Elon is spending that $10 billion on. And I didn't think
hmm
about this until just now. That
yeah,
number seemed like it was too big for the amount
hmm
of Dojo compute they were buying and the amount of H100s they were buying from NVIDIA. And to me, one of the things that makes sense is that they were actually paying TSMC a large
hmm
amount of upfront capital to help them put into, like, because TSMC is going to have to invest a bunch of money to develop. Like, this is a new process, so it's going to require new hardware, huge capital investment, probably had to be made by TSMC in order to bring this
yeah,
Dojo V1 chip up in production, and or Dojo, we'll call it the V1.5 chip up. And so it wouldn't surprise me if a portion of that $10 billion actually went to TSMC, not to
yeah,
NVIDIA, and not necessarily just to purchase the V1 chips themselves, but to
yeah.
enable the production of these V1.5 chips, which is all
So
exciting.
yeah, and so when we hear all the layoffs, it's as long as they're spending that money in AI, robotaxi, on bots, on the kind of the new definition of what Tesla is, it's it's worth it. It's important to do the reorganization. So just to finalize the thinking here of what's happening. So this new tile is likely going to be used for Tesla's new planned $500 million Dojo cluster in New York. But separately, Tesla is building a new 100 megawatt data center to train its self driving AI at Gigafactory, Texas. We were told that this system is going to use the NVIDIA hardware. So again, they have both systems, they're using
Yep.
both. How can you not, like everyone else out there has, I have to buy NVIDIA or that's it. These guys, Tesla has got, plan B, but also plan A, plan B add together, 2 plus 2 is equal 5, right? So it's going to be
Yes.
amazing.
And the reason that that's probably going to be the case for for the near term, and the reason that Elon needs those H200s, is
Yeah.
this lack of memory that's available to the Dojo V1.5 chip when they put it on the wafer.
Mm.
Um, it can be an incredible, like, it's going to be an incredible piece of AI compute that can do a lot of things, but it's not going to do everything. And the one thing that it's not going to be able to do that they still need to do is the largest training runs on the biggest neural nets. And so that's what
Mhm.
they're going to need, the H1 or the the Nvidia chips, which are the H100s that they have, the H200 chips that they're
The new
buying. They're
H200s.
still going to
Yep.
be using those, but
Yep.
then they're also continuing to produce, and this is, if you look at any of the hyperscalers, they're doing this too. They're buying lots and lots of Nvidia compute, but then they're also all developing their own. Google has TPUs, AWS has their own chips, Azure has their own chips,
Yep.
and they're using their other chips to handle other types of workloads, and they're purpose building them for whatever that workload is, so that it's cheaper to produce the chips, it's cheaper to run the workloads. And right now, that's kind of what the Dojo chip, like, that's where it lives currently. But the innovation that TSMC is talking about, where we can go to these 3D chips and we can put our high bandwidth memory on top of our chips,
Mhm.
that will allow there's no guarantee that they will replace NVIDIA, but it will enable this brand new architecture, this brand new way to build AI compute. It will enable that to potentially compete with, and even over the long term, will probably completely disrupt the way that NVIDIA builds their GPUs. There's going to need to be a lot of investment, a lot of software, a lot of hardware innovation left between here and there. But this is potentially the thing that makes GPUs actually obsolete in comparison with the new future of AI hardware.
Wow. Thank you so much, Hans. I learned a lot. It's great to get, people that are smarter than me, that are experts. Thank you so much. This is good. Hans, you got to follow him on his YouTube channel, Hans C. Nelson. Thank you guys. Thanks, everybody. Bye bye. I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.